All right, guys. Hey, welcome. 8.7 Factoring Special Products. So today, the goal is this. We're going to factor binomials that are the difference of squares. Okay, I'll show you what that looks like. And then we're going to factor trinomials that are perfect squares. Okay, so these are kind of special products. They call them special products because they're special circumstances when we factor. Okay, so, excuse the line there. Man, why won't this let me scroll? There we go. Okay, so first of all, you guys, let's just review what a square is. Okay, so a square, if you have a square, okay, any square, we know that the length and the width, or the base and the height, if you will, are the exact same on a square, right? All sides are the same. Okay, so notice here why we call it a square. If you had a 2 by 2, it would be like a 2 by 2 squared, right? 2 squared is 4, right? Because if you have a square that with a length of 2, the area of that thing would be 2 times 2, which is 4, right? So squaring is kind of like another way of finding area. If you had a 3 by 3, okay, you'd have something like this. 3 squared is indeed 9, okay? So that is what a square means, and what it is multiplying the same thing by itself, right? You multiply something by itself to get an answer. Okay, so we reviewed some of these. You may want to write down all the perfect squares up to a certain point. 7 squared would be 49, right? 8 squared, I'm not going to do all these for you, but 8 squared, and then you can do 9 squared, etc., etc. You might want to have those handy. Okay, so I guess I want you to do this on scratch paper. Find answers using the distributive property. Okay, so I encourage you to stop the video, try this out yourself, but here we go. I'm just going to cruise through it. If you do this, you guys, notice that we're foiling. X times x gives you x squared. X times negative 3 gives you negative 3x. 3 times x gives you positive 3x. And 3 times negative 3 gives you negative 9. Okay, so notice what happened to the negative 3x and the positive 3x. Negative 3x plus 3x is 0. And I'm left with x squared minus 9. Okay, today we're going to be doing the reverse, where they're going to give you this and ask you to come up with the factors. So you can kind of guess where that's going and what the rule is. If I do it with number 2, I'm going to use the same strategy. X times x is x squared. X times 6x is plus 6x, negative 6 times x is negative 6x, and negative 6 times 6 is negative 36. These go away, and I'm left with x squared minus 36. Okay, if I do this with just an a and a b, I would have a squared plus ab minus ab, right, minus b squared. These go away, and I'm just left with a squared minus b squared. Okay, so I'm hoping you notice the pattern here. Whenever I have two things squared with a subtraction sign between them, it has to be a subtraction sign between them. This is called a difference of squares. And it will always factor to the first thing squared minus the second thing squared. Okay, when you FOIL it out. If you're going the other way, sorry, I shouldn't have said factor there. When you FOIL it out, that's what you'll get. If you're going the other way, though, okay, if you have something like x squared minus 9, it'll always be the root of x squared, which is x, okay, plus the root of the second thing, which is 3 in this case, because the square root of 9 is 3. Times the opposite factor, x minus 3. Okay, so I'm just showing you the reverse. Okay, so we'll look at the rule again here in a minute, but I'm just showing you where this is going a little bit ahead of time. So let's scroll down to this guy. It says to factor x squared minus 25. When I go to factor this thing, I'm noticing that this is a difference of squares. Okay, so this is a difference of squares, which means that I'm going to have the root of x and the root of 25. I'm going to have one with a plus sign, one with a minus sign, and I'm done. Now notice, when you FOIL this back, x times x gives you x squared, x times negative 5 gives you negative 5x, x times 5 gives you positive 5x, those go away, and then 5 times negative 5 is negative 25. So notice in this quadratic, there's no middle term, there's no x term, right? And this is perfect, this is perfect. When that happens, it's always going to be, the factors will always be the root of the first terms plus the root of the second term, and then minus. Okay, so that's how it'll always work. So what happens when both factors are positive? Well, let's just FOIL this out to see. X times x is x squared. X times 3 is plus 3x. 3 times x is plus 3x. And 3 times 3 is 9. So notice this is much different when you have a plus sign there. Okay, you end up with this. All right, so that's much different than what we were talking about up here, where the middle term dropped out. So the middle term will only drop out when you have a negative sign. It's called a difference of squares. Okay, so I wanted you to be in partners to factor this one together, but you can just pause the video and try this on your own. Let's try this one. X squared plus 4, this is the sum of two squares. Okay, so can we factor this? That's the question. Is this factorable? So we're looking for two things that when you multiply them out, they're going to give us this back. So x and x makes sense, right, to give us the x squared. But is there anything we can do here to get that 4? You would think 2 and 2, but then what sign would you use? If you used a plus sign for both, you would get x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. Okay, so that's not the same as that. If you did a plus and a minus, you'd end up with this. Okay, if we do this out, we get x squared minus 2x plus 2x minus 4. These go away. You'd get this. Okay, but it turns out that there's no way to factor the sum of two squares. So when this is a plus, this is called the sum of squares, and it is not factorable. Okay, if they gave us this problem, that is factorable. And it's because of this idea that we created up here. Okay, so the difference of squares is what we're talking about here. Okay, the key is to get something into the form of something squared minus something squared. So here, if we're given something like this, we want to write it as something squared minus something squared. Okay, in parentheses, squared. So think about this. If we take the square root of 16, we would have a 4. Okay, if you take the square root of h, you have h. So this is going to be a little bit of a stretch for some of you guys. That's okay. Notice if I take 4h and I square it, 4h times 4h is just 16h squared, right? So I'm rewriting 16h squared in this format. Okay? I'm going to do the same thing with 9a squared. Okay, so 9a squared. The square root of 9 is 3. The square root of a is a. A squared is a. If you were to multiply 3a times 3a, you should get that 9a squared back. So 9a squared, when you multiply it, 3 times 3 is 9. 8 times a is a squared. Okay, once it's in this form, you guys, we have a difference of squares. Difference of squares will always factor to the first thing, the square root of the first term, which is 4h, plus the second term, times the square root of the first minus the square root of the second. So that is my answer, my factor to that guy. All right? Okay. So let's try this again. again, my strategy is going to be to write it in this format of a squared minus b squared. So 121, how can I write that as something squared? Well, 11 squared gives you 21. If you didn't know that, you could take the square root of 121, and you'd find that it's 11. Okay, minus something squared. So notice we cannot put a 4 in here. We have to take the square root of 4, which is 2b. Okay, because you can always check yourself. 2b times 2b, right, which is what 2b squared is, would be 4b squared, which is what I wanted. Okay, once I have this, I want to then write it out. Square root of 11 squared is 11, minus the square root of 2b squared, which is 2b, and then 11 plus 2b. Okay. With this one's fascinating. I don't know that I want to get into this right now. I guess I will. With this one, I can't write this as something squared minus something squared right now. Okay? But notice I could take out a g because I have g's in both, and I can also take out a 3 because I have 3's in both. So the first thing you always do when you factor, you guys, none of these had common factors, but if you see something that's in common with both terms, take it out. Okay, so if I do that, I could take a 3 out, I could take a g out, and what I'm left with is 9g squared minus 1. Check this. Do I have a difference of squares here? Can I write this term as something squared minus this term as something squared? Well, 1 can be written as 1 squared. The square root of 9 is 3. The square root of g squared is g. So I can write that as this. And so yeah, it did work, right? And I also have this 3g that I took out. Okay, now I know I'm moving a little fast here, and that there's probably going to be questions about this, but we'll do some more examples, don't worry. Okay, so what this factors to is the 3g stays out, and then I got to rewrite this, right? So this would be 3g minus 1, 3, and the order doesn't matter that you do minus or plus, doesn't really matter. But one of them has to be positive, one of them has to be negative. Okay, so that's how that one works. All right, so I'm going to do example 1 with you and example 2 with you on this video, and then I'll probably follow up with another video for the others. Okay, so example 1. It says determine if the polynomial represents a difference of squares. If so, factor it. So when they're asking you that, you guys, they're asking you, can you write it as something squared minus something squared? Can 81 be written as something squared? Well, take the square root of 81 to find out. When you do, you get 9. So 9 squared is 81. The square root of c squared is just c, right? So I can write that as c squared. Whatever's in these parentheses are your factors. So we have 9 plus c, 9 minus c. All right, so that's example 1. Let's look at 1c. Can I write this as something squared minus something squared? Well, here's the big idea, guys. It's a difference of squares. If I see a plus sign, I already know this is no, right? If it was a minus sign, then I'd have to check it, but it's a plus sign. So this cannot be written as a difference of squares. This one, we have a minus sign, so we got to check it. Okay, so can this be written as something squared minus something squared? Okay, 64 has a square root of 8. G squared has a square root of g, so that can be written like that. H squared can be written like this, so yes, we do have a difference of squares. Okay, the factor would be this guy and this guy. We have 8g plus h and 8g minus h. Okay, this is called the difference of squares. All right. The final thing I'm going to teach you on this video is factoring perfect square trinomials. In fact, maybe not. I think I'm gonna stop this video here. I'll move into factoring perfect square trinomials on the next lesson.